Welcome, ladies and gentlemen, to Randolph Soundstage. I'm Randolph Tim, and in this series we're going to explore the world of sound. We're going to study what sound is, how it's made, how we hear it, and how to control it. This is my little home studio where concepts are born, experimented with, and ironed out before it's being taken into the studio. Remember, time is money, and studio time is real money.
Yeah, darling, gonna.
In this episode, we're going to explore the characteristics of sound a little deeper and how we can use that knowledge to get the sound we are looking for in the studio and on the stage. Later, we'll touch on a couple of inexpensive or expensive instruments that we can use to help us get the sound we're looking for and avoid problems. I hope you'll join us for the future videos, and we'll be using what we learn here as a foundation so that we know what we're doing and we know what we're talking about when we walk into the studio and set up the stage. So with that said, here's all about sound. No matter the dimension of decibels, decibels is a ratio to a reference level. In other words, this sound is twice as loud or half as loud as that sound. 3 decibels represents a ratio of 2. Plus 3 dB is twice as loud as 0 dB. Minus 3 dB is half as loud. 0 dB is the reference level. The reference level can be any absolute level. So 53 dB is twice as loud as 50 dB. 56 dB is plus 3 or twice as loud as 53 dB. Okay, 47 dB is half as loud as 50 dB. 44 dB is 1/4 as loud as 50 dB. So this is one place where 2 plus 2 does not necessarily equal 4. Now there is an absolute acoustic dB scale that is used occasionally, particularly with sound pressure level meters. And in that scale, the reference level is 1 dB, which is the softest sound the human ear can perceive. And that is also the minimum difference that the human ear can perceive as you go up the scale. If you hear a sound that's 50 dB on the sound pressure level meter, and you increase the volume control, you are not going to hear a difference in level until 51 dB, okay? And keep increasing it, you're not going to hear another difference in level until you reach 52 dB. Speaker efficiency is sometimes specified as an SPL at rated wattage, or another wattage, often 1 watt, at a certain distance from the speakers, often 1 meter or 1 foot. A couple of things to note here. There is no SPL for an absolute value or an absolute signal level of 0, because that would require division by 0 or the logarithm of 0, neither of which exists. 0 dB always refers to 2 signals of the same level or amplitude, or a level that is too soft for the human ear to hear. Electronics use decibels to reference power levels and signal levels, and even those two are 2 different scales. It's important to know which decibel scale you're dealing with, and here's why. As shown in the diagram of the power amplifier, 6 dB of power ratio is a power ratio of 4:1. 6 dB of acoustic ratio translates into a power ratio of 100:1. This can make a big difference in the sound you get. The sound equipment for studio and stage are almost always scaled in acoustic decibels because that's what sound people work with. It is important to get a good balance between the individual parts, and that is especially true in the studio. Let's move on to frequencies and wavelength. The frequency spectrum of human hearing runs from around 20 Hertz or cycles per second to around 20 kilohertz or 20,000 cycles per second on the high end. Most good sound systems are designed around those specifications. It's important in designing and recording music to keep them in mind. The ear likes to hear the full spectrum. That's why we have bass drums and bass guitars and guitars and cymbals. Wavelength is simply the speed of sound divided by the frequency, and it is the distance sound travels in one cycle. For these exercises, we will use Wikipedia's reported speed of 1125 feet per second. The speed will vary somewhat depending on medium, its density, temperature, and humidity. I've measured it at around 900 feet per second in Kansas in an air-conditioned building. We will see in a while why wavelength can be important. One characteristic of sound that we haven't looked at yet is its ability to reflect off of surfaces, just like light. If a sound wave at a particular frequency reflects off a wall or possibly several walls, it is possible for the reflection to arrive at some areas in the venue 180 degrees out of phase with the primary and cause dropouts at a particular frequency. There really isn't much you can do about this. Moving speakers around is just going to move the area of the dropout. The point here is, don't try to correct the condition with the soundboard or the EQ. You can't. The other side of the coin is, the reflection might arrive in certain spots in phase with the original wave and reinforce it, bumping the level of that frequency up a couple of decibels in that area. If a live mic happens to be there, this can cause unwanted feedback. This can be corrected with the EQ, but at some expense in sound. Bump the level of the mic back a couple of decibels until the feedback goes away, or use the EQ to bump the treble frequency down to kill it. Your sound may drop out at that frequency band, but the crowd won't mind. Try moving the mic back before doing anything, and remember, dropping the mic back more than a couple of decibels will seriously hurt the sound if it's a main vocals mic. Backup vocals not so much. For the best of both worlds, use a dedicated EQ on an effects end for the mic channel and run the mains without EQ. That way your dropouts will only occur on the problem channel, the vocals, and the instruments will run clean. I have a 6-channel 120 watt PA built by Custom back in the 60s that has built-in spring reverb and a 6-band EQ just for this. It's a gem. Just for information, the wavelength of a 40 Hz wave is around 28 feet. A half wave would be around 14 feet. If a wall is 14 or 28 feet away, the return wave will be in phase and reinforcing. The wavelength of a 4 kHz wave is a little over 3 inches. That's why higher frequencies present more reflection problems. It's also why they call it a crash cymbal. If you consistently have feedback problems from the stage monitors, you might seriously consider going to wireless earplugs for monitors. Or try pointing the monitors to the sides in front of the mics instead of to the back wall of the stage. Some venues have their back walls insulated, but many do not. Band shells are designed to reflect and focus the sound. One instrument no sound person can afford to be without these days is an SPL or sound pressure level meter. You can pick one up at the Play Store for a few dollars a year well equipped. The one I use has a histogram display and calibration capability, as well as maximum and minimum peaks on flat dB and max peak on the histogram. It does roll off pretty sharply after 8K, but hey, even if you go for a handheld, it does not hurt to have one on the phone for those special occasions. You can pick up a standalone for anywhere from $15 and up. The Galaxy CM130 from Sweetwater runs around $60 and is a very sweet lab quality unit. The CM170 available from B&H is a little spendier, around $300, but offers data logging with clock, a USB interface, and a bit better accuracy, plus minus 1.4 dB. We'll examine several techniques for using these babies to get the sound you want while avoiding stage fright in our next video. You won't want to miss it. I hope you enjoyed this piece of Randolph Soundstage, and if I imparted a piece of useful information or sparked an idea, well, that's even better. Future videos in this series will explore other aspects of sound and sound electronics that are essential to consistently setting up a stage and getting the sound that works on stage or in the check out the other videos and playlists that you see here, and please be kind.